Welcome, algebra class. Today we're going to talk about functions. I hope you're comfortable and I hope you have your thinking caps on because functions are not the easiest thing in the world. A lot of times in algebra, when these are first introduced, I have kids just holding their heads and not understanding, and hopefully this will make sense today. I think of functions kind of like a machine. I'm going to use this box as kind of a very low-tech machine. Let's say that we have certain things. Let's say I have a white pawn. I put it into the box, cover it up, and magically out comes a white queen. Okay? That's kind of what the idea of a function. I'll come back to this box in a second. So in simplest terms, a function is a set of domains. Remember we talked about that yesterday when we talked about relations that map onto a set of ranges. Okay, we did that yesterday. We had x values, we had a set of x values, and we had a set of y values. And we could show this map in a map here. Let's say that there was a 2, a -3, and a 4. And this 2 is associated with 3, this -3 is associated with 0, and this 4 is associated with a 1. That is both a relationship, but it's a specific kind of relationship called a function. A function is a set of x values or domains that map only onto a specific one range. In other words, you can't have 2 related to 3 and to -5. That's not okay. So again, with my low-tech example here, if we had a black pawn, I put it into the box, covered up magic, out comes a black king, that's acceptable. If I had another white pawn, I put it in, cover it up, change it around, and out comes a knight. At first that seems acceptable, but then you notice that also out comes a rook. Suddenly that's not a function. It's a relationship, it's a relation, but it violates our rules for functions. Any specific domain can only have one range value. Sometimes people get this mixed up because it is acceptable. Let's say I had there was 2 and maybe 3. I stick 2 in, and I'm related to 3, and I stick 3 in, and that's also related to 3. That's acceptable. Do you see it doesn't violate our rules? Each specific domain has one and only one range value. Now the fact that these two have the same value here, it doesn't really matter. If you think about this graphically, there's a kind of handy test, and it's called the vertical line test. If what I'm saying is, in any set of x and y's, let me just put a couple in here, -3, and it turns out to be 1. I put into my machine -1, and it comes out 2. And I put into my machine 3, and it comes out 4. First of all, you can ask yourself, is that a function? I'll stop for a moment. You pause the video, think about it. What'd you think? Function, yes or no? Well, there's 3 specific domains, and they each have one and only one range value, and so that's fine. It's a function. We can graph this very quickly. -3 and up 1. Put a dot there. -1 up 2. Oh, sorry. -1 up 2. And over 3 and up 4. And if I connect these dots, it'd be something like that. I don't know where it goes after that, so I'll just leave it like that. There's a handy test called the vertical line test. It only really works if you see it graphically, but if it's graphical, it's a very quick test. And if you think about it, what it means is, or what it says is, if I just draw a vertical line anywhere, if it crosses this line of values at only one point, then it's a function. And if you think for a moment what that means is, that basically is saying that all the, for any x that you go, it's not going to have more than one y value. Because let's say that over 3, we had a value of 4, right? Well, let's say it also had a value of -2. Suddenly, I don't know what my graph's going to look like. It's going to look weird. But if I try to do the vertical line test, it's going to hit 2 separate points. Because there's 2 y values associated with one x value, which violates the whole functional notation, the relationship. And so it's no longer a function. Sometimes you'll see functions represented like this. They'll say f of x equals x plus 1. This is kind of like the y value. And we can just simply represent that like this, x and y. So stick in a number here, 0. And the function of x is going to end up being 0 plus 1 is 1. Stick in a number 2, 2 plus 1 is 3. Stick in a number -5, -5 plus 1 is -4. Is it a function? Yes. Here's what the function looks like. Here it is in a table. If you map it, it would each go, let's see, it's 0, 2, and -5. And they each have their own specific range. 0 goes with 1, 2 goes with 3, 5 goes with -4, -5 goes with -4. So it's a function. Now, if at this point you're still a little fuzzy about functions, we're going to practice tomorrow. Okay? It's a relation, and it's a little bit more. It's something special. It's a function machine. Most equations with variables are going to be functions. Actually, I should say most equations with like 2 variables. So like if y equals 2x plus 3, it's a function. Again, you can stick in numbers for x and you'll get a specific value for y. All right, we'll work with this more, and throughout this year, as we talk about functions, it's going to get more and more clear. At first, I know it's a little bit tough, but if you have problems, come back to this video, remind yourself what a function is. And it's a series of domain numbers that map onto a specific range number, not more than one range number. X's that go to a specific y. Okay?